Hello my friends and welcome back to the You Can Do TV channel. Mahman Dam construction shows steady progress. Diversion tunnel inlet and outlet portals are underway, along with major works at the spillway and power intake. The powerhouse and switchyard sites are actively developing. Key infrastructure includes the Bailey Bridge, Todobo Quarry stockpile area, re-regulation pond, crushing plant, and batching plant, supporting the overall construction and logistics chain efficiently. First, the area was leveled and the tunnel route was mapped. Then, the experts used a flatbed truck as a mobile frame, which acted as a support and alignment during the installation of the arch. The system was designed to be modular, allowing easy movement between different vehicles, suitable for many construction site conditions. On the truck body, roller supports are arranged with a radius that gradually narrows towards the rear, allowing the precast arch blocks to be joined together with precise curvature. The rollers are specially designed to withstand large loads without deformation, ensuring stability during construction. The construction site must be carefully prepared, flat, hard, and non-sagging, to avoid structural deformation during construction. The result is a fast tunneling system that does not require permanent support. In Peru, the Pala 6040 ACFS electric hydraulic shovel is now in operation, marking a significant step toward cleaner mining. Unlike traditional diesel-powered shovels, the 6040 ACFS produces no direct air pollution, helping reduce the environmental footprint of heavy-duty mining. With a powerful and efficient electric drive system, it ensures high productivity while cutting emissions and maintenance costs. Its capacity to load large haul trucks efficiently makes it ideal for high-volume operations, contributing to safer, greener, and more sustainable mining practices in the region. The Komatsu 575 Superdozer is the largest production bulldozer in the world, capable of pushing up to 180 tons with its 1,200 horsepower engine. It can be operated manually or by remote control, enhancing safety in hazardous environments. Filmed at Stockton's Solid Energy coal mine near Westport, New Zealand, this machine is owned by Kaipara Limited, which operates the only 2 units in the country. Globally, only about 70 exist. Remote control helps prevent injuries if the dozer encounters unstable terrain or mine shafts. House connections with ELGF tapping saddles, GF piping systems. Begin by cleaning the pipe surface. Unpack the ELGF Plus tapping saddle without touching the fusion zone. Position the saddle, tighten the screws, and mark the location. Scan the QR code for fusion parameters and traceability. Clean the fusion zone with Tanget PE cleaner. Start the fusion process and monitor it. Mark the pipe's insertion depth, then unpack and install the coupler and ball valve, avoiding contact with fusion areas. Use a clamping tool if needed. Verify fusion indicators and mark completion. Close the ball valve, retract the cutter, and confirm the pipe section is cut. Hand tighten the screw cap and mark the tapping. Finally, mount the extension spindle for operation. Manhole installations require a watertight seal between concrete structures and connecting pipes. The Hamilton-Kent 3S series push-fit connectors offer a simple, cost-effective solution. Begin by measuring and cutting the pipe to the correct length, accounting for insertion depth. Chamfer and deburr the ends, then lubricate both the pipe and connector. Insert the pipe carefully, ensuring alignment. For manhole base installation, clean the trench, lift with proper equipment, and lubricate the pipe and outlet. Lower and align the base. Then push it into place until it seats against the third step. Avoid hydrocarbon lubricants. They compromise the connector's sealing performance. At first glance, the B16 near Unterhausen seems like just another federal road, but take a closer look, and it becomes clear. This is a test section for a pioneering pilot project. Within just 30 hours, an entirely new road surface is being installed using an innovative method known as compact asphalt, or compact asphalt. This process allows for the simultaneous laying of 2 asphalt layers in a single pass, delivering high-quality road surfacing in record time. The pilot stretch spans 3.3 kilometers and replaces severely worn traditional asphalt, where surface and binder layers have long since separated due to rising traffic loads and heavier axle weights. A total of 8,600 tons of AC32TS asphalt base course and 1,320 tons of SMA8S mastic asphalt surface layer will be applied, hot on hot, ensuring perfect bonding. Work begins with a 1,000 horsepower cold milling machine removing the old pavement. The reclaimed material is then transported to mixing plants in Ginderkingen, Ebenhausen, and Augsburg, where it's processed into recycled asphalt. Each site contributes to a combined output of 430 tons per hour to meet the tight schedule. Once the roadbed is cleaned and a bitumen bonding layer is applied, a specially constructed compact asphalt paver begins work. With precise sensor control, it lays both layers simultaneously across the full 8.15 meter width without the risk of cold joints. Temperature, density, and thickness are continuously monitored, ensuring consistent quality. This approach brings key advantages: faster installation, minimized traffic disruption, improved bonding and resistance to deformation, longer lifespan, and better sustainability. Even sensor-embedded transponders are installed for long-term monitoring of temperature, compaction, and material performance. With edge sealing and road marking completed, the new B16 stretch reopens on schedule. Thanks to this modern dual-layer system, road users benefit from greater grip, lower noise, and a surface built to last. Truly a double layer that pays off in every way.
The Brokk 160 is a cutting-edge, remote-controlled demolition machine designed for safe and efficient concrete floor demolition. Weighing 1,600 kilograms, it can handle attachments up to 270 kilograms. The machine is powered by a robust electric motor, delivering over 406 joules at the tip with its standard hammer, which can be replaced with a crunching jaw or digging bucket for versatile applications. The Brokk 160 is operated via state-of-the-art digital remote control, allowing for precise and safe control from a distance, significantly reducing the risk to operators. This lightweight yet powerful machine is ideal for medium to heavy demolition tasks across various industries, including construction, cement, mining, tunneling, metal processing, and nuclear sectors. Its design emphasizes safety, efficiency, and versatility, enabling users to accomplish challenging demolition tasks while minimizing physical strain and maximizing productivity. Zero-slump concrete that pumps easily represents a significant innovation in construction, particularly for building walls without the need for traditional forms. This method leverages a specialized admixture, 3D admix, to modify ready-mix concrete, enabling it to be pumped directly into place. Upon delivery to the job site, thickeners and accelerators are injected and intermixed within the pumping line. This transforms the fluid concrete, providing it with zero-slump characteristics while maintaining workability.
We can do it without anything at all, or just something to define the geometry of the wall that will be in.
The use of normal weight aggregates without fibers in these test projects adds an extra challenge to achieving zero-slump pumpability. Remarkably, these tests are conducted using a 1970s Mako grout pump, a machine not typically associated with handling stiff mixes. However, this system demonstrates that even older, less powerful pumps can effectively manage this modified concrete, showcasing its versatility and efficiency. In practical applications, a more powerful pump would further enhance the process, making it faster, easier, cleaner, and more cost-effective than traditional shotcrete methods. The potential for this method to streamline construction projects is significant, offering a rapid and economical alternative to conventional wall building techniques. Moreover, the mix demonstrated in the video is particularly suited for 3D printing applications. Sourced from a batch plant, this concrete mix is substantially cheaper than typical 3D print materials. It also offers the advantage of an extended open time, remaining workable for several hours if necessary. This site is in Newcastle, UK. This team is engaged in the load-in and load-out assembly of jackets for the beach project. Over the past few weeks, they have assembled the SGC 120, and today it will undergo a load test before being handed over to the client. The SGC 120 is one of the world's most massive cranes. Compact and powerful, it can lift over 3,000 tons. Its low ground-bearing pressures allow it to be erected on site with minimal civil works impact. With the ring already installed on load-spreading steel mats, construction of the mainframe begins. The deck panels are first placed on top of the crane frame, followed by the hydraulic winches and power packs, which ensure reliable load raising and lowering. Next, the two back masts are assembled. Despite its might, the SGC 120 operates efficiently in tight spaces due to its compact ring design. It performs heavy lifting on offshore platforms or nuclear power plants without disrupting other site work. As the first back mast is raised, the team uses temporary bracing to secure it. The crawler crane is then detached, and the second back mast is raised. Once the back masts are in place, the connection between the two structures is installed. Next, the counterweights are loaded. 36 ballast containers, each weighing 100 tons and packed with locally sourced materials, are placed onto the platform. With the counterweights ready, the cables are connected. The bridles are reeved using thin cables to guide thicker ones into place, and the two back mast cables are connected. The pre-assembled main boom is then installed. The bridles are connected to the boom, and the winches are wound to tension the bridles. The pre-assembled hook block is then reeved, with a rope pulling the steel cable through the pulley. This cable guides a thicker one from the winch through the pulley. Finally, the hook is installed, and the massive crane is prepared for load testing. Assembling a crane like the SGC 120 is a substantial project, requiring significant space, a 45-meter ring footprint and a 130-meter long boom. Additionally, a decent-sized crawler crane is needed to install the 100-ton counterweights, of which there are 36. However, all this effort results in a crane with a lifting capacity of over 3,000 tons. Permanent shotcrete stabilization using Titan micropiles is an efficient and reliable method for securing structures. The installation process is straightforward and involves connecting a pressure grouting plant to a drilling rig, with the hollow steel bar serving as the drilling rod. The installation is carried out using rotary percussive drilling while injecting a drilling, flushing fluid. The drilling rod is easily extended with couplers, allowing for seamless progress. Once the desired depth is reached, dynamic pressure grouting with a grout suspension begins. Further excavation can proceed once the anchors and shotcrete facing have cured, allowing for stable excavation shoring to be built incrementally. Titan micropiles have a variety of applications. They are used as compression piles for foundations and underpinning, tension piles for tying back retaining structures, and in tunneling. These versatile applications demonstrate the adaptability of Titan micropiles in different geotechnical challenges. The core of this system is the self-drilling Titan micropile, which effectively transfers loads to the subsoil. These micropiles can handle tension, compression, and cyclic loads, making them suitable for securing various structures in diverse conditions. Approved by the Deutsches Institut für Bautechnik, DIBT, for permanent applications exceeding 100 years, Titan micropiles offer numerous advantages for different stakeholders. The M-System Blue Mesh welding plant operates by preparing cross wires and line wires from coils, ensuring precise alignment and readiness for welding. Cross wire preparation involves straightening and cutting wires to the required lengths, while line wire preparation ensures consistent feed and positioning. These wires are then welded together to form reinforcement meshes, with high precision and strength. The welded meshes are automatically supplied to a magnetic traverse system for efficient handling and further processing. Additionally, the plant can perform Z-shaped bendings on line wires, enhancing the structural integrity of lattice girder floors. In the workflow, every item intended for casting into the panels, including reinforcements and lattice girders, is detailed at the initial design stage. In-house engineers carry out all design calculations, which are then incorporated into the 3D model created by draftsmen. Once the design is finalized and approved by the client's design team, the model is electronically transmitted to the factory's host computer. Upon receipt, the electronic information describing the 3D model is sent to the plotting station, where each concrete element is accurately marked out. This data includes the panel shape, cutouts, and cast-in items like electrical boxes and conduits. Magnetic shutters, after being cleaned for precision, are positioned along the plot lines, and casting items are secured to the steel pallet. Next, the pallets and shutters receive a final coating of release oil, and any small joints are sealed to prevent grout loss, ensuring the highest quality panels. The pallets then proceed to the reinforcement station, where spacers are placed. The automated robotic steel machine at this station draws steel from coils, cuts, bends, and positions it according to the 3D model specifications. This automation ensures precise placement of steel reinforcement, including any links for hidden beams within the walls or floors. Lattice girders, which hold the twin walls together, are also cut to length and placed at this station. Following this, the pallets move to the station where the steel is tied and lifting hooks are fitted. Conduits and additional casting items are placed, and insulation is measured for size to be added later. Plastic-coated steel rods are placed at set intervals to maintain the required thickness between the two concrete skins of the twin wall. The concrete, produced on-site in the fully automated batching plant accredited to N206 for concrete quality, is then ordered by the operator. All aggregates used in the concrete production are also manufactured on-site, ensuring consistent quality. The concrete spreader collects the thoroughly mixed concrete and evenly distributes it over the reinforced steel on the pallets. Air is removed, and the concrete is compacted using a computerized pallet oscillating platform, guaranteeing high-strength concrete with a premium finish. This process completes the production of the first skin of the twin wall, which is then sent to the heat curing chamber. Controlled by the host computer, this chamber can hold up to 36 pallets, each individually tagged for immediate recall. The following day, the production of the second skin begins, following the same steps as the first skin until it reaches the concrete shaking station. Here, it waits for the first skin, which is automatically retrieved from the curing chamber, turned over by the Volar returning crane, and placed onto the wet concrete of the second skin. Both skins, now on a single pallet, are returned to the curing chamber to cure sufficiently for demolding. After sufficient curing, the twin wall panel is removed from the storage chamber by the rack operator. To prevent damage during demolding, the panel is placed on a tilting table and then removed by a twin hoist crane. Finally, the panel is loaded onto one of the custom transport vehicles for delivery. For filigree floor slabs, the process is similar. Once removed from the pallets, the slabs are directly placed on trailers for delivery to the site. Both types of panels are transported from the factory to the installation site.
The crawler crane weighs nearly 200 tons and requires 4 trucks for relocation. One truck carries 60 tons of counterweight over 5 axles. Another transports ballast containers and accessories. The third hauls the undercarriage. The crane disassembles itself using 4 hydraulic legs and can load its parts onto trucks independently, ready for the next job site. An insulated tilt wall panel is a concrete wall system designed for thermal performance in temperature-controlled buildings. Unlike traditional panels, insulation is sandwiched between 2 concrete layers. First, rebar is placed in a wood form and covered with a partial concrete pour. While wet, rigid foam insulation is laid on top, followed by fiber composite connectors to secure the insulation. After curing, a second rebar layer and final concrete pour complete the panel. Once cured, panels are lifted into place, providing strength, durability, and insulation in one integrated unit. Autoclaved aerated concrete, or AAC, is a lightweight and highly insulating building material. When applied vertically in wall panel form, AAC panels offer a quick and efficient alternative to traditional bricklaying. These vertically installed AAC wall elements are prefabricated in a range of standard sizes and arrive on site with embedded transport reinforcement, making handling and placement safe and easy. The panels are designed to fit seamlessly together with tongue and groove connections, ensuring a strong, airtight structure with minimal thermal bridging. Installation begins with accurate positioning of the base channel, ensuring the panels are set level and plumb. Then, using a crane or manual lifting tools depending on panel size, each panel is guided into place. Thin bed adhesive is applied at vertical joints to secure a solid bond. Once in place, fast anchoring systems fix the panels to the slab and ceiling, providing lateral stability. This system drastically reduces labor time, eliminates the need for additional scaffolding, and offers superior speed in wall construction. Vertical AAC panels are commonly used in residential buildings, offering excellent fire resistance, sound insulation, and energy efficiency. From single-family homes to multi-story apartments, AAC vertical elements are a modern, clean, and sustainable solution for fast-track construction. From the first layer of mortar to the final ceiling slab, we'll see how precision, materials, and smart engineering come together to build a durable, energy-efficient home. After completing the earthworks and concrete slab, masonry work begins on the brow solid house. The first step, laying a bitumen barrier to protect the walls from rising moisture. The foundation slab is then leveled with cement mortar to compensate for any height differences, essential to ensure all bricks lie perfectly level. Construction starts at the corners. A laser ensures precise height control. Once the first corner brick is set, all others align to it. Wall openings, like doors and floor-to-ceiling windows, are planned precisely from the blueprint. Braille uses Poriton clay blocks with integrated hydrophobic mineral wool. This monolithic masonry system delivers top-tier thermal insulation and soundproofing, without requiring an external thermal insulation composite system, ETICS. The result: breathable, vapor-permeable walls that regulate interior humidity naturally. The first course is laid with thick bed mortar. Starting from the second course, a thin bed adhesive mortar ensures a strong bond with minimal joint thickness, ideal for energy-efficient construction. Exterior walls rise quickly. A second moisture barrier tops the second course, forming the insulated base of the structure. The interior walls follow, using two sizes of Poriton blocks, 17.5 centimeters thick for load-bearing, 11.5 centimeters for partition walls. Construction mirrors the exterior process, precision with lasers and guides. The ground floor ceiling consists of filigree concrete slabs set on temporary props, reinforced with steel, and cast in place to form a unified floor structure. Within just 10 days, the Braille Villa's 2 floors are fully walled and structurally complete. A fast, efficient, and thermally optimized building method, engineered for performance and durability. The stadium's roof is a world first in design, requiring 40 million pounds of steel for support. Ironworkers face immense challenges, using the largest American-made crawler crane to lift each section. This was just one of over 100 trusses needed for the fixed part of the roof. In total, thousands of steel components will be installed, each playing a crucial role in bringing the iconic Mercedes-Benz Stadium to life. The reconstruction of the Jettenbach hydropower plant marked one of Germany's most advanced infrastructure projects, With an investment of 250 million euros, VERBUND began by reinforcing the existing weir and intake structures while preserving the historic powerhouse. In Jettenbach, rebar installation for the outflow slab began in May 2019. In Toging, over 100,000 cubic meters of soil were excavated to accommodate the new powerhouse adjacent to the heritage-listed structure. The excavation was stabilized using 420 board piles, each drilled to depths exceeding 70 meters to ensure slope and load. By 2020, formwork, waterproofing membranes, and reinforcement cages were installed across a 30-meter deep construction pit. Precision concrete casting followed, including turbine spiral cases and suction tubes, assembled from multi-piece timber formwork and cast in place with high-strength concrete. Heavy lifting operations played a central role. A 13-ton suction draft tube lining, a 28-ton turbine shaft, and a 110-ton stator were each installed using specialized mobile cranes. Rotor alignment and stator fitment were performed with millimeter accuracy to ensure optimal magnetic gap and turbine efficiency. Transformer bays were integrated directly into the machine hall structure with pre-tensioned concrete roof elements, up to 17 meters long, installed by crane. By early 2022, 3 Kaplan turbines, each tuned for high efficiency under variable flow conditions, were commissioned. Their combined output, 118 megawatts, powering 200,000 homes. A feat of civil, hydraulic, and mechanical engineering, delivered on time, on budget, and ready for the energy future. Today, China is the most powerful and advanced country, listed #1 in every field and sector below, among which in many fields China's outputs are not just #1, but also larger than that of next 20 countries combined. China's high-speed railway construction is globally recognized for its incredible speed, scale, and technological advancement. One of the key reasons for this success lies in the use of elevated bridges and viaducts. By building railways above ground, China reduces land acquisition issues, avoids obstacles like rivers and roads, and improves ride stability. These structures form the backbone of the expanding high-speed rail network, now stretching tens of thousands of kilometers across the country. At the core of this system is the box girder bridge. Each box girder weighs up to 1,000 tons and is manufactured through a strict 42-day cycle involving 9 stages and 18 processes. From raw steel to final form, these girders are designed to endure the harshest conditions, such as extreme heat, freezing cold, strong winds, and heavy rainfall. Once delivered to the site, the girders are bolted into place to form a solid and continuous track foundation. This prefabrication and modular assembly approach significantly accelerates construction while maintaining tight quality control. Equally impressive is the rail laying process. China deploys a specialized machine that can install dual tracks at the same time, laying 30-ton steel rails that are 500 meters long. This machine also places 200-kilogram concrete sleepers underneath, spaced precisely 60 centimeters apart. Despite handling such massive components, the machine requires only 7 workers to operate, making the process highly efficient. This cutting-edge system allowed the Dazheng high-speed railway to complete its 280-kilometer dual-track project at astonishing speed. China's integration of engineering precision, automation, and logistical scale has made it a global leader in rail infrastructure. The entire process, from girder fabrication to track laying, reflects world-class innovation and sets a benchmark for future transportation megaprojects. The SLJ 900 bridge girder erection machine is a colossal engineering marvel built by Beijing Wow Joint Machinery Company. Weighing 580 tons and stretching 91.8 meters in length, this beast stands 9 meters tall and spans 7.4 meters wide. Designed to lift up to 900 tons, it revolutionizes bridge construction. Its joint-dominated triangular structure allows self-stabilization without anchors, resisting overturning forces during span transitions. The JP three-wheel train mechanism ensures smooth support. With constant drive on the main support leg, synchronized motion enhances safety and precision. Through alternating functions of its support legs, it spans piers without a guide beam, ideal for tunnels and complex sites. Truly, a giant among machines. A site visit was held at the Stone Bridge, which spans 485 meters with 5 segments. It is part of the €526 million road connectivity with Southern Dalmatia project. Completion is expected by the end of 2025.
Automation in reinforcement production revolutionizes the manufacturing process by incorporating advanced technologies and robotics. At this facility, the implementation of 3 robot-assisted EBA automatic stirrup benders and a state-of-the-art M-system mesh welding plant with a bending system exemplifies this transformation. These technologies, coupled with innovative, fully automated transport logistics and integrated software products, streamline production and enhance efficiency. The automation process begins with the robot-assisted stirrup benders, which precisely shape and cut the reinforcement stirrups. These robots not only handle the bending but also change the bending tools autonomously, ensuring continuous operation with minimal human intervention. The stirrups are then transported just in time to the mesh welding plant, where they are incorporated into wall panel cages. Automated logistics systems manage the transport of stirrups and other materials throughout the production facility, ensuring they are delivered to the correct locations at the right times. This reduces manual handling and increases the speed and accuracy of the process. The integration of these automated systems results in significant labor savings, enhanced productivity, and improved product quality. The automatically adjustable staircase ramp mold with landing offers advanced versatility for construction projects. This mold allows for electric-driven automatic adjustment of the ramp's inclination and the landing's inclination. It incorporates inclination sensors to adjust the rise of each step and ensure the landing's angle is consistent with the ramp's slope. Additionally, the length of the staircase or landing can be varied to meet specific project requirements. The staircase mold provides seamless control over the number of steps and step dimensions through an electrical control system, enhancing flexibility in staircase design. The lateral shutters are hydraulically operated, facilitating easy adjustment and modification. This automatic control system, along with the ability to integrate vibrators and heating systems, ensures high surface quality and faster curing times. The mold is available in both pure steel and a steel-wood combination, offering maximum adaptability for different staircase designs. Concrete ceiling vent cuts and removal are intricate tasks that require specialized equipment and skilled personnel. Concrete is a prevalent material in construction due to its strength and durability, making modifications challenging. This is especially true for ceiling vents, where precision and safety are paramount. To facilitate concrete vent cuts and removal, electric saws are the preferred choice. These saws are capable of cutting up to 15 inches deep and can operate along any horizontal or vertical plane. Their electric nature allows for both indoor and outdoor use, ensuring minimal dust production and maintaining a clean working environment. This team of expert technicians utilizes these industrial-grade saws, which combine brute force, sharp blades, and hydraulic support to make precise cuts. This advanced technology simplifies concrete cutting, allowing for efficient and effective completion of even the most complex jobs. Whether the task is to modify, repair, or remove a section of concrete, skilled workers are equipped to handle the demands, ensuring high-quality results in sensitive environments. The Brokk 500 is an advanced demolition robot designed for powerful and precise concrete wall removal. To remove a 2-foot-thick concrete wall while maintaining 3 feet of rebar around the perimeter for re-tie back, the Brokk 500 utilizes its 40% increased demolition power compared to its predecessor. The robot is equipped with a 41 kilowatt smart power electrical system and can handle heavier attachments, such as a powerful breaker, making it highly effective for demanding tasks. The extended working reach and radius allow the breaker to access and demolish large sections of the wall efficiently. Its reinforced design ensures durability and stability during the demolition process. The divided hose connection and big-size grease container facilitate easy maintenance and operation, while the breaker unique control system provides precise handling and control of the machine. Reinforced headlight protection ensures visibility and safety during the operation. The robot's ability to precisely target and demolish specific sections of the wall allows for the careful removal of concrete while preserving the rebar around the perimeter, ensuring it remains intact for future re-tie back. The Impactor 250 slow-speed concrete shredder is an exceptionally versatile and compact machine designed for efficient shredding of various materials. With a powerful 220 horsepower engine, it is capable of grinding, crushing, and shredding concrete, rubble, asphalt, bricks, ceramic, metal, wood, and waste. The shredder features a patented dual-shaft design that ensures precise cutting and reduces energy consumption. Special shaft geometry positions materials to be crushed, while secondary double jawbreakers and breaker bars produce a uniform final product size. This machine is also equipped with an auto-reverse function that protects the cutting tools and minimizes wear part maintenance. The Impactor 250 is compact, measuring 22 feet in length, 7 feet 10.5 inches in width, and 9 feet 2 inches in height, with a weight of 29,763 pounds. It offers short setup times and tracks for exceptional maneuverability. Additionally, it is available as a stationary electric unit. Key specifications include 59-inch shafts with speeds ranging from 11 to 45 RPM. Experts used hydro-demolition to rehabilitate Basin 1 at the historic Florence water treatment plant. A robot was employed to direct high-pressure jets of water to remove the old layer of concrete. This process leaves behind a rough exterior, which is ideal for applying new concrete. The hydro-demolition robot operates by using high-pressure water jets to remove old concrete. Controlled remotely, the robot moves across the surface, directing water at specific areas with precision. The Power Curber is a versatile multi-purpose slip-form machine designed for a range of offset and paving applications. This machine stands out for its ease of operation and adaptability, making it an ideal choice for contractors involved in various types of work, including barrier construction, bridge parapets, ditches, and road paving. The Power Curber is designed for productivity, featuring individual hydrostatic pumps for each crawler to ensure smooth paving even at low speeds. Vibrators are individually adjustable and linked for system-wide adjustments using proportionate master control. The conveyor is robust enough to handle challenging concrete placement conditions for large offset applications. Additionally, secondary sensor on-off controls located on each leg allow crew members to adjust sensors from the ground, aiding in maneuvering around obstacles while pouring. In paving mode, the machine is a fully functional road paver, equipped with dowel bar, tie bar, and center bar inserters. It also features hydraulic sides, edge overbuild, and crowning capabilities. Optional features include a tamper bar, auger or plow, and finishers. In offset mode, the machine can handle large applications, such as barriers, tunnel work, ditches, and paths up to 12 feet wide. Selective demolition of an 80-foot concrete silo posed a unique challenge due to its proximity to an active farmhouse. The task required precision to prevent damage to the nearby building. The Brokk 100, a versatile and agile demolition robot, was crucial for this job. It was hoisted into position using a telehandler, allowing the operator to work efficiently with minimal manual labor. The majority of the rubble was directed inward, ensuring that no large pieces fell towards the farmhouse. The Brokk 100 excels in confined spaces, able to fit through standard doorways and navigate stairs. It operates via wireless Bluetooth or an umbilical cable, and can be equipped with various attachments for braking, crunching, and digging. This machinery minimizes hand-arm vibration, fumes, and noise, enhancing safety and reducing environmental impact. The use of the Brokk 100 significantly reduced labor costs and time, while ensuring all employees remained safe within the controlled demolition zone. This method demonstrated how advanced demolition technology can effectively manage complex projects with precision and safety. This example of a qualification panel showcases a nozzleman expertly placing wet mix shotcrete using the bench method. Initially, the nozzleman creates a bench at approximately a 45-degree angle, forming a stable foundation. The subsequent layers of shotcrete are applied perpendicularly to the previously placed material, minimizing the occurrence of skipping and rolling. This approach ensures a consistent and even application, essential for structural integrity. As the nozzleman progresses, they continuously adjust the distance and angles to maintain an optimal receiving surface. This dynamic control is crucial for achieving uniform thickness and adherence. The wet mix shotcrete, applied with precision, avoids buildup at the front of the reinforcing bars. Instead, the material wraps around the bars, building up from behind, which ensures that the bars are thoroughly encapsulated. This method allows the deformations on the bars to remain visible until they are fully encased, confirming proper coverage and integration. Throughout the process, the nozzleman's skill in managing the flow and direction of the shotcrete is evident. By adjusting the nozzle's distance and angle, they can ensure that the material is applied evenly and adheres properly to the substrate. This meticulous attention to detail is critical for achieving a high-quality finish and maintaining the structural integrity of the shotcrete application. The bench method, with its perpendicular layering and precise control, exemplifies best practices in wet mix shotcrete application.
This time-lapse captures the full installation process of the Offshore Fisheries Science Vessel 1, CCGS Sir John Franklin. Spanning 63.4 meters in length and displacing 3,212 tons, the Sir John Franklin was designed to support fisheries science and ecosystem research along Canada's Pacific coast. Built by Seaspan Shipyards in Vancouver, construction began with steel cutting and modular fabrication. The ship was constructed using a block building method. 37 steel modules were prefabricated and assembled into larger blocks. Each module, ranging from the double-bottom hull to the stern and superstructure, was carefully aligned and welded into place using massive gantry cranes. Precision was critical, as every section had to match flawlessly to ensure hull integrity. Once the structural blocks were joined, internal outfitting began. This included the installation of complex piping systems, electrical wiring, engine components, and onboard scientific labs. The superstructure housing navigation and control systems was lifted and secured last. The ship's signature red and white paint is applied before it's launched into Berard Inlet for final sea trials. Final stages involved system integration, ballast testing, and initial sea trials. The installation phase required exact coordination between welding teams, crane operators, and marine engineers, all working to meet rigorous government and naval standards. The result, a fully operational state-of-the-art science vessel ready for deployment along Canada's coasts. Step into the world of Royal IHC at its Krimpen aan den IJssel and Sliedrecht shipyards. The Sapura Diamante is a 145.9-meter pipelaying vessel with a 29.9-meter beam and accommodation for 120 people. It features a 550-ton top tension tower positioned in front of the moon pool to optimize deck space. To pass under Brazil's 48-meter air draft bridge, the tower's upper sections can fold down. With a max draft of 8.3 meters and deadweight of 10,070 tons, the vessel successfully completed sea trials and was delivered on May 27 to Sapura Navegação Maritima. Australia Pacific LNG on Curtis Island features 2 LNG trains and 160,000 cubic meters tanks. Using the optimized cascade process, gas is chilled to minus 161 degrees Celsius. In the world of heavy machinery and high-stakes construction, the margin for error is razor thin. When things go wrong, the consequences are not only costly, but potentially catastrophic. This compilation of extreme crane fails and heavy equipment disasters showcases how a moment of poor judgment, a small mechanical fault, or simply bad weather can lead to absolute devastation. Our first incident takes us to where workers refused to lift a 50-ton coil due to dangerously high winds. But a supervisor insisted, taking full responsibility. The result? Total failure. The coil never moved, and 2 massive cranes, rented from another company, were wrecked. A stark reminder that arrogance has no place on a job site. In Pakistan's Buner marble quarry, a truck overloaded with stone lost its brakes on a mountain road. It collided with a rock wall and overturned. Thankfully, the driver survived. But it begs the question, was regular maintenance neglected? Next, we witness an excavator pushing a crane on rails. Too fast, too heavy. The crane couldn't keep up and toppled. Another failure unfolded at sea when a crane transferring cargo suddenly collapsed. Likely due to brittle fracture in Russia's extreme cold, the result was a bone-chilling plunge, fortunately without injuries. Snowy conditions added danger elsewhere. An excavator slid while unloading from a truck. In a ship's cargo hold, a careless operator dropped several containers, highlighting the danger of untrained hands on powerful machines. A tragic story occurred in 2012 in Bogorodskoye, Russia. A tower crane carrying 4 workers collapsed. 3 died. The company distanced itself, blaming a third-party rental. The loss, however, remains permanent. Another jaw-dropping moment involved a gantry crane being lowered using a truck crane as a regulator. The supports were extended along rails, but under its own weight, the gantry collapsed, crushed by the very forces it was built to control. In one case, a crane lifting a steel frame lost balance and nearly flipped. Quick reactions and counterbalancing saved the day. Others weren't as lucky. At a site with improperly compacted ground, a crane attempting to lift a loader tipped violently, a brutal lesson in foundational preparation. Finally, in Peru's Piscobamba region, a Chavin Express bus was buried in a sudden landslide. As crews tried to recover it, the structure collapsed again, highlighting how unpredictable and unforgiving nature can be. These incidents are more than viral clips. They're real-world reminders that heavy equipment demands respect, expertise, and constant vigilance. Because when 100 tons of steel turns against you, there are no second chances. A sideways tractor trailer clings to the slope, seconds from disaster. The load didn't dump. The trailer tipped, but the driver lived. Shaken, scraped, but unbelievably lucky.